Well, great. If there's nothing else from the panel, we'll open it up to the audience for questions for Brad and Jamie. Can you walk to the microphone? And the procedures we need to use the microphone because of the TV broadcast. And if you can introduce yourself with your name and affiliation, if you have one.
My name is Hal Shepard. I'm with the Center for Water Advocacy, and I guess my question is mostly for Jamie, and I may not be fully updated on the process here, but it's my understanding that the seems to be kind of missing from this discussion is the reclamation of some 11 miles of water that runs through the mining site. That habitat, that stream flow will be gone as a result of the mine. And if that is still the case, then how does what you have been presenting apply to restoring those flows?
Okay. I mean, what I presented today is just the baseline flows, the natural condition of the watersheds as they stand now. And that I'm not addressing what the potential mine effects are or what they plan to do at closure or anything of those factors. But the information that we collect now in terms of the baseline will give them a guide as to A, how much water they're dealing with, potentially how much water they may be cutting off or changing in terms of predicting what kind of flow patterns might, and also what they're targeting for closure in order to try and restore the system back to the way it was. So that's really all. This is just the baseline information that's then used for all going forward in terms of trying to assess A, what there was so we can get back to it, and B, what the effects might be. So,
okay.
Yeah.
And I was at a technical advisory group meeting yesterday for the Susitna hydro plant that they're proposing up on the Susitna River.
Yeah.
And that was an all-day meeting in which they talked about, well, of course, that power plant will affect flows to some extent. They're not actually talking about taking flow out and then putting it back in to that extent.
Right.
But they talked about, in relation to in-stream flows, they talked about fish habitat, how that's going to be affecting habitat, how that's going to be affecting riparian, how that's the fluvial geomorphology will play into that, temperature. And I didn't really see any of that in your discussion at all. Is that going to be part of this picture? If you're actually talking about putting a stream back together,
yeah.
Is that going to be part of that?
Sure. Again, I'm just dealing with quantity of flow. There's another group that deals with all the fisheries and all the consideration in terms of how the flow changes might affect fish, may affect their habitat, that sort of thing. But that's completely outside my area of expertise. All I do for them is tell them how much water is there now and what are the patterns in the watersheds. Like where do we see the water and when does it come? You know, that sort of thing. So okay. It's just all I'm dealing with is the baseline condition of flows at the moment. But rest assured, they are considering the other aspects of it within another group of consultants and experts.
And we should mention next week there's panels discussing fishery, wildlife, and socioeconomic. So not necessarily, and again, it's the baseline data. It's what the existing conditions are, but with the thought of, well, there's going to be potentially a disturbance and implications. So I don't know if you were aware that the fisheries part is next week.
Yeah, I understand that.
Okay.
And I think they're doing the same thing, again, using the analogy of the Susitna project. They're talking about all those things separately, but they're also talking about flows in the context of fish, habitat, riparian, just flows. And that took an all-day discussion yesterday, and they're out in the field today. It's a 3-day meeting, basically.
Yeah, well, so I work very closely with the fisheries guys as well. Okay. So if they want to ask, what's the flow like here at this time of year, that sort of stuff, we supply them with that. If they say, if they are going to get into the effects assessment and say, can you predict what this development, how that will change the flows in this instance at this time of year in this creek, then they look at the different fish species, life stage, et cetera, and say, oh, that's going to have a negative effect or a positive effect or whatever for this type of fish and this type of, you know, that sort of thing. So it's not, we are doing our own pieces, but it all works collectively. I mean, I have input to the fishery studies, I have input to all the engineering studies, all the rest of it. So this is just looking at how much, the first step is to figure out how much water we've got there and what kind of water flow patterns do we naturally see? And then we can look at how might they change in the future as a result of different developments, and how then would that affect fish resources or other resources or other users downstream.
Thank you.
Yeah.
We have one question that came in via email from Randall Hagenstein from the Nature Conservancy. A question regarding return interval of hydrologic events. Given the long persistence of likely tailing storage facilities, as described by the panel yesterday, and given the history of multiple glacial advances in the site, what is the predicted return interval, or what was the past return interval for glacial advances in both the deposit location and the transportation corridor?
I haven't. That's outside my area of expertise. I haven't dealt with.
So we should. Well, we should. I mean, this is the hydrologic surface water hydrology panel, and Jamie and Brad have different expertise, but Chris Way Thomas may have a comment on this for Randall.
Yeah, I mean, just in general terms, the last glacial period to affect the area occurred between about 25,000 and about 11,000 years ago. So that was the last one. Before that, there was a period of glaciation that occurred roughly 60 to 80,000 years ago, not nearly as extensive. Then there was an interglacial period before that, about 125,000 years ago, and then a period of glaciation before that. So what's that frequency? That's about every 30,000 years, roughly. So I think we're good for a while.
And that would be both for the mine site location and the transportation corridor.
Right. Now, it's debatable whether we're entering into a period of global cooling, global warming, where we are with regard to global climate. So hard to say when the next ice age might really appear.
Great, thanks.
Yes, my name is Jim Brown, and I'm mostly retired from Alaska Pacific University as an environmental geologist. So my question is for Brad, and it's prompted by some of the discussion from yesterday in terms of the physiography in the soils. A comment was made about possibility of relict permafrost within the mine site and perhaps the transportation corridor. So in terms of your temperature readings, what sort of numbers would you say you have in terms of like mean annual temperatures recorded in terms of, are we below freezing, above freezing, or right at zero?
Well, the data table, I don't know if one can put that back up, that I presented earlier, it shows it pretty cyclical. There hasn't been a long period of record out there to assess trends over time to extrapolate out. But we historically see the cooling trends following the typical wintertime, summertime changes. So I think it's probably about 2 slides after that would have the temperatures. Yeah. So you can see, it's warming up in the summer and it's cooling. It's cooling off in the wintertime. I guess I'm struggling with where to go to answer your question beyond that. The period of record for the measurements is way too short, and like Chris had mentioned, you could debate whether we're in a cooling trend or warming trend to go beyond that.
I was just interested in the present, what you did find in terms of mean annual numbers. Are you 5 degree, sort of mean annual temperature for like 5 or degrees above freezing? Or
if you average those numbers.
Yeah, I'd have to
Can
do
you
the
repeat?
math. Yeah, I'd have to do the math. I don't have that information immediately available.
Thank you.
Dave Albert with the Nature Conservancy here in Alaska. To Jamie, very impressive data set. I appreciate the presentation. And so in terms of predicting the magnitude of average flows, low flows, 100-year event, 200-year event, things like that, what if the climate in the future doesn't look like the climate in the past? and have you, so how do you address that, and do you have a sense of what to expect, or so what's your approach to that kind of thing?
It's the $1 million question, or more. Climate change is always a point of discussion. Generally, the consensus seems to be that the climate is generally around the world warming at the moment, and the rate of warming seems to be relatively unprecedented in terms of recent time, anyways. Where it's going to go, I'm not sure. Even I have actually, on behalf of Pebble, looked at the climate trends in the area of the Pebble project. And to be honest, the temperature has changed very, very little over the last century in terms of the temperature trend for mean annual temperatures. If you look at the last 60 years, it has gone up quite a bit. But if you delve into even further, the climate patterns here are very closely tied to what they call the Pacific Decadal Oscillation. Okay, so it's the surface water temperatures in the North Pacific. And there was a very, very, very strong transition from a cold phase to a warm phase in 1976 or 77. So the last few years we've been in a warm trend, and the preceding 30 years was essentially a cold trend. So most of the data sets in Alaska are after the Second World War. So they cover the cold trend, the cold phase, and then this warm phase. And you draw any trend line through that, and you're going to see a dramatic positive shift. There are a few data sets, such as NOME, which goes further back. And if you draw the trend line through that, it's much, much flatter. So the consensus seems to be that we appear to be moving into a cold phase now. And typically the PDO has about a 30-year cycle. Who knows exactly, because it's never exactly 30 years. So if we were to move into a cold phase for the next 30 years, you may see a drop in the temperatures. But anyways, overall, there's probably a slight increasing trend. We also have modeled sort of, if we took the runoff that we actually have a watershed model, and the inputs to it are precipitation and temperature, and it predicts the flows. And so what we did was we actually took the temperatures and boosted them all and saw what effect would that have on the flows. And the biggest effect it has, and again, there's some debate as to what's happening with the precip, because a lot of people are predicting increasing precipitation. But what it really changes the most, because with warmer temperatures you also get increased evapotranspiration. Is that going to counter that or not? So the jury's a bit out. But overall, the bottom line is what the biggest trends are, or most evident changes, are the shape and the timing of the flows. So we'd likely see a slightly shorter winter period and a slightly warmer winter period. And so we'd see an earlier onset of breakup and freshet, that sort of thing. And so we actually get a different distribution of the runoff. It sort of tends to be a slightly different shape. And you wouldn't get as big a snowpack because it's a bit warmer and the winter's shorter. So you have a sort of smaller freshet peak and that sort of. So we've looked at those sort of changes already. And I can't guarantee that's what's going to happen, but that's kind of what. But in terms of the peak flows, the other thing that comes into play is the jury's completely out on that. I've looked into it quite a bit because peak flows is kind of my thing. But what the general consensus is, if you don't know, then add a little bit of safety factor. So we often add, the state of the art right now is to take your peak flow estimate and add about a 10 or 15% factor and boost it a little bit and say, okay, that's, at least provides some margin of safety to the number. So we actually do that when we're doing engineering design. We incorporate, okay, here's our estimate based on what we have. What's the uncertainty of that number? Don't forget the climate change factor. We usually add a little bit of thing. And that's about as far as it goes. I can't really give you with great certainty, what's going to happen. And again, that's a projection of, okay, over the operating life of the mine, that's what we're looking at. Okay, so then if we're looking at closure, what would happen with closure? Well, typically what would happen if you had this large tailings facility is you would actually have to provide what you call a giant closure spillway. So in other words, if the flows got really high in there for some reason, you wouldn't take out the dam, it would go over the spillway and go. So then you size that thing with a huge extra margin of safety in it. And so that problem maximum flood event, which is the largest event that could never occur, gets boosted even more. And and if you think hydrogeology is a black science, you should see PMF analysis, which is this problem maximum flood thing. So there's a lot of uncertainty in that, but the engineering side of it is we do incorporate we do consider climate change in that factor. Now, again, there's all sorts of other things that climate may change in terms of, you know, in the north here, there's big changes with permafrost and all those other implications, and maybe warming of the creeks and how's that going to affect the fish, and changing the, in terms of, you know, if the creeks are warmer, is that going to initiate all the reds coming out earlier, you know, in terms of all those other factors. That's really outside my realm, but I do try to account for climate change and at least inform the others that might be using the information what potentially and where the general trends are going. So, all right, thanks.
What do the global climate models say?
The global climate model.
You've been addressing some other things, but you didn't mention any of the GCMs. I'm just curious what they say about this area.
I'll be honest and say I'm quite skeptical of the global climate models. But anyways, that's another issue. But the global climate models, depending on which scenario you choose, you know, you're familiar with the global climate models. There's all these different scenarios. Yes, and the one that's commonly quoted is, I think it's scenario 2, which talks about sort of our production of greenhouse gases is going to continue on at a certain rate, and that the climate, world's population is going to increase at certain rates, and all these sort of things. So all those factors come into play. They are actually predicting much warmer temperatures and higher precipitation. Yeah, that's what they are saying.
For southern Alaska?
Yeah, I mean, it's a big, the effects are greater in the north. Mm-hmm. But even southern Alaska.
That seems to be verifying this year. I mean, with 21% or 23% of global, or of Arctic ice cap.
Yeah.
You know,
yeah.
minimum ever seen, stuff like that. Seems to be verifying pretty well.
Right.
So.
As I said, I mean, the general consensus in the world, but the rate at which it's changing stuff, you know, those global climate models have a massive, if you look at the error bands on the ranges of estimates that they come up with, it's very dependent on the scenario that you decide to use. So a lot of studies that go on often say, okay, we're going to study what the effects are, but first off, we're going to state right now, we're assuming scenario 2 of a global climate model. We're just accepting that that is what's happening, and now we're going to study what are the potential effects and what we could maybe do about it. Mm-hmm. Nobody's going to argue that that is absolutely certain what's going to happen. Not. I mean, so the general consensus is things are warming. That's, you know, but the effects tend to be felt greater in the north than in the sort of the lower half of Alaska. But the trends in the current data sets that we have over the longest ones you can find is that the biggest effects are these climate cycles. So a lot of people, I mean, it's very hard to predict climate change. They're talking about a very large, long-term thing. And then a lot of people are familiar with, I know when I was a kid, the snow was, you know, this high every year, but you were only 4 feet tall. So, you know, you get that all the time. So you have to put it in the context of, you know, really what do we know? And I would have to admit that it seems to be warming, and the general trend is warming. But to predict what it's going to be next year or 5 or 10 years down the road, the climate cycles are having a much bigger effect than the overall climate change. That's my personal opinion, but that's what the data seems to tell me.
A question from the audience?
Yeah, I'm off duty now, so I think I get Jeremy Richards, University of Alberta. It's maybe something I misunderstood from when we were talking about volcanological risks before, but I understood that we had said that the wind direction was primarily going to come from the southwest and was going to blow volcanic ash up the chain. But what I got from your talk, Brad, was that the main wind direction is actually from the southeast, and just to the southeast of us is Augustine volcano. So, in fact, is that most likely to be the greatest volcanic ash risk? And the follow-up question to that is, if that's the case, is there any evidence in the water systems for lahars, for mud flows, any evidence that this has happened in the past, where you get volcanic ash and gets remobilized in the streams, because lahars are much more dangerous and damaging than just high water flood?
Well, I can tell you the answer to your second question is I'm not the qualified person to answer that, so I'll defer that to someone else. In answer to the first question, the data at the Pebble 1 mine site shows the predominant winds representative of the siting of that instrument. So that instrument is measuring winds at roughly 30 feet above ground. And when you're talking about volcanic ash, you're talking about different layers of the atmosphere and the predominant wind directions there. So you're talking about a different scale of magnitude. We aren't measuring, I'm not measuring at least, or familiar with the data there to really answer that question. But I don't think that the data suggests a conflict. There's just a different factor at play there.
So the regional wind flow is still generally from the southwest? Is that what you're saying?
The immediate area there, the vicinity of the mine at that area, that height of representatives that is generally used by the air quality models to then assess dust impacts and such, to Chris's question.
Right. But do we know collectively what the regional wind direction, the high altitude wind direction is that ash is likely to come
NOAA
from?
does have information on it. They've got satellite studies and other things like that does characterize that. I just don't have that information.
Anybody know?
Yeah, well, what Brad says is absolutely right. So he's measuring surface winds, and the winds that we're talking about with regard to ash distribution are winds aloft, so winds 3,000 feet and higher. So these are measured in various places around the state, but also determined from satellite data. And this information can be obtained off the internet, and we would routinely use it for ash distribution modeling and be concerned about stuff that's 20,000 feet and above. So,
Thanks. Are there any other questions from the audience? In the panel, are we? Oh, here's a question.
My name's Brian Coyle, and I'm unaffiliated, but kind of a follow-up to the little brief discussion on global climate change. Loved your answer. Glad to hear you're looking at that. I'd like to point you to some recent work done by Jennifer Francis on perturbations to the jet stream caused by melting of the ice cap. And her thesis, that's first paper I saw was this year, and she's going to be presenting at AGU this year, saying that not looking at a global model so much as increased frequency and duration of extreme events. In particular, how this might be incorporated into your studies of increased flows, what you can expect, that whether it's warming or cooling, at least we can see in the short-term cycles we'll have more extreme events and longer lasting storms. So you might have less snow or more snow, but it's all going to come at once, and same with the rain.
Right. Yeah, that is actually one of the general conclusions from most of the studies, is that you are going to see there's greater, call it, with warmer temperatures, you got more energy in the atmosphere, creates greater volatility, and you see more, the frequency of extreme events increases. So you're going to see, and that's where we come into play of how do we adjust the peak flow estimates that we come up with, or extreme precipitation estimates that we come up with. How do we account for that? And I'd be really interested in seeing if she can help quantify that, because I know it's there. It's just how do I put a number on it? Is the real engineering side challenge, because we want to create a number. So generally, as I said, the state of the art, if we want to kind of, is to put in a I don't know. I mean, to be honest, it's called the fudge factor, right? We just add a safety margin to the estimate that we've got. We boost it up a bit. And that's according. That's kind of the state of the art at the moment. If there's anything out there that could help point that in a slightly sharper direction for me, I'd really appreciate it.
Yeah, as far as quantifying it, I don't know, but
yeah.
they're definitely actively ongoing research in that area by that group. So
right. Okay. Well, thank you very much. Yeah, it's great.
Is there any other questions? I think Todd has a bit of information he wants to share before we adjourn.
I don't have a lot of information to share, but I just wanted to thank the panel and Jamie and Brad for their work. And I thought it sounded like a great discussion, and most of this one I actually think I did understand, so that was good. I wanted to sort of set up the day tomorrow, so it's a same kind of structure. Tomorrow's kind of our water quality day, and that's the third day of this panel. And then, of course, as you heard, we have panels next week as well on Tuesday, Wednesday, and Thursday. So we're really hoping that we can get the same kind of interesting and valuable discussion about that. So we've got tomorrow we've got groundwater hydrology and water quality. We wanted to let you out as soon as we could because as far as I know, the presidential debate is tonight and it starts at 5. Yeah, so we weren't sure if you guys were on like what kind of time zone you're on in terms of when you get that kind of coverage, but it sounds like you get it early. So anyway, we'll just I guess we'll just conclude now and then and let you all depart, and we can certainly stick around. I don't think we'll do an evening session. We were talking about a 7 p.m. session, but I don't think we'll do that this evening. We may want to do one tomorrow evening if people want to stick around and talk about water quality issues, so keep that in mind. So thank you very much, and we will see you tomorrow.